Hello students, in this video I am going to go through solving a system of quadratic to quadratic equations. So let's take a look. So this, what I have here, okay, are two pairs of equations that are second degree. So what do I mean by second degree here? I noticed that I have an x squared here and I have a y squared there. Okay, so what I'm going to do is I'm not knowing about like what types of graphs these are or what types of like relations these are. I'm going to attempt to try and solve this using just my understanding of algebra. Okay, so what you want to do, okay, is we want to eliminate as many things as we can. Okay, so what we're going to try and do, okay, is we're going to try and eliminate either x's or either y's. Okay, so by the way it looks right now, it looks like a pretty good approach here is to eliminate the y's, right? So what am I going to do to accomplish this? Well, what I'm going to do is I'm going to multiply the top equation there by 8, okay? So thereby giving me 8x squared minus 8y squared minus 80x minus 64y minus 120 is equal to 0. And then the bottom equation is x squared plus 8y squared minus 10x plus 64y plus 120 is equal to 0. And I get to this point right there. And so if I add the two equations, what will I get? I'll get 9x squared. The y squares goes away. The x's become negative 90x. The actually, I'll write it in the correct place order. So it's right here. And then the y's will go away. And the 20, the positive negative 20, that will go away. Right? So all of this will equal to 0. So now I'm just left with this really simple 9x squared minus 90x is equal to 0 equation. And I need to solve for this. So if I divide both sides by 9, I'll end up with x squared minus 10x is equal to 0. And notice right now this thing is factorable. I have x times x minus 10 is equal to 0. X therefore will equal to 0 or 10. So now that I have this, okay, what I need to do is I need to then take this and put it back into either the top equation or the bottom equation. And quite honestly, they're both like really like annoying. But it looks like maybe perhaps the top equation is a little simpler because there's like less coefficients to deal with. So I'm going to substitute it into the top equation there. So I'm substitute 0 into the top equation, and what will I get? I'll get 0 minus y squared minus 10 times 0 minus 8y minus 15 is equal to 0. And at this stage, actually I'm going to use a different color just to make it stand out a little more. So I get negative y squared minus 8y minus 15 is equal to 0. I'm going to divide both sides by negative. I'll end up with y squared plus 8y plus 15 is equal to 0. Is this thing factorable? Indeed it is, right? Y plus 5 and y plus 3. So therefore I'll end up with two y coordinates. I'll end up with y is equal to negative 5 and negative 3. Now how does that work? One x coordinate having two y coordinates? Well, this is just saying, okay, that at x coordinate 0, there's going to be 2 points of intersection. I'm going to have an intersection at 0, comma, negative 5, and another intersection at 0, comma, negative 3. All right, we're going to repeat this again, okay, for the second coordinate, 10. So if I pop in 10, I'll end up with, I'm going to use another color. Let's use green, okay? So if I pop in 10, I'll end up with 100 squared, okay, minus y squared minus 10 times 10, which is minus 100. Sorry, the first one is not minus 100 squared. It's minus 10 squared, which becomes 100. So 100 minus y squared minus 100, and then minus 8y minus 15 is equal to 0. So if I simplify this, again, I'll end up with negative y squared minus 8y minus 15 is equal to 0. And look, we get to a very, very similar situation here, right? Divide both sides by negative, y squared plus 8y plus 15 is equal to 0. Or in other words, this thing is factored into y plus 5 and y plus 3. So we get another pair of points, which are 10, comma, negative 5, and 10, comma, negative 3. Okay, so these are the points of intersection. Whoops. Let's try that again. Number 11. All right, so same idea, okay? What we're going to do is we're going to try to eliminate variables here. So looking at this, okay, looks like I'm pretty primed to eliminate the y's, right? So the y squares can eliminate because they have the same coefficient. Same thing with these. So what I'm going to do, okay, is I'm going to line these things up. Actually, they're kind of lined up already, so I'm just going to jump right in and do the subtraction. Okay? So I'm going to get rid of this. Hold on. All right. So if I perform the subtraction, whoops. If I perform the subtraction, so positive x squared minus 10x squared, that's negative 9x squared. Y squared minus y squared, that's 0. 2x minus 20x, so that's minus 18x. 2y minus 2y, 0. Negative 14 minus negative 149, so that becomes plus. Plus how much? 135, right? And this all boils down to, well, is this thing divisible by 9? It looks to be divisible by 9. I'm going to divide both sides by negative 9. And if I do, I'll end up with x squared plus 2x minus, what is that? 9 goes into 135 15 times. Are there two numbers that multiply to negative 15 but add to 2? As a matter of fact, yes. That would be x plus 5, x minus 3. So I again end up with x is equal to 5, or negative 5, or positive 3. So now what I'm going to do is I'm going to pop the equation back into either the first or second equation, and depending upon which one's the easier one, that's how you're going to make your decision. It looks like maybe perhaps the first equation is the easiest. So again, over here, if I pop in negative 5, I'll end up with 25 plus y squared plus 2 times negative 5 plus 2 y minus 14 is equal to 0. Perform a little bit of simplification. I get y squared plus 2y. 25 minus 10, that's 15. 15 minus 14, that's 1. So it's going to be plus 1 is equal to 0. So this thing is a perfect square. It's y plus 1. So therefore y is equal to negative 1. So here one of the coordinates will be negative 5 comma negative 1. Let's do the second set of coordinate. And over here in green. So again, I'm going to pop in 3. So I get x squared, so that's 9, plus y squared plus 2 times 1 plus 2y minus 14 is equal to 0. I want to combine all like terms. I get y squared. 9 plus 2 is 11. 11 minus 14, that is negative 3. So it's not y squared plus 2y minus 3 is equal to 0. Okay? So are there two numbers that multiply to negative 3 but add to positive 2? Yes, indeed. So that's y plus 3, y minus 1 is equal to 0. So what are the solutions then? So my second solution is going to be 3 comma negative 3 or 3 comma positive 1. Remember, y here is equal to negative 3 or positive 1. And that corresponds with the x-coordinate 3 there. So this is my answer here. I have 3 answers.